All right, I'm back. It's another day. I got a little time, so we're going to start the process of purification. We've dissolved all the gold from the fingers in the mixture of hydrochloric acid and bleach. It's all in here, but there's a lot of impurities in there. There's a lot of dirt, there's a lot of crud, there's some bits of conformal coating, some bits of plastic and fiberglass, and of course there's a filter that I used earlier, all floating around in there. And we want to purify this. We want to get it just as close to a pure liquid as we can. We want to get rid of all that solid stuff. So I'm going to filter it. I'm going to filter it again with, since I'm working, assuming somebody's just getting started out in this and wants to do it on the cheap, because let's face it, you haven't made any money at it yet when you're starting out. So you can't really afford to go out and buy a bunch of fancy lab equipment. So I'm going to do it with, again, coffee filters and a plastic funnel. But coffee filters really suck for fine filtration. Anybody who's ever looked at the bottom of their coffee cup after they've drunk all of it, you can see all the sediment down there. So a lot of stuff gets through coffee filters. So one way I found to get better filtration is I stuff a cotton ball, or two, if I want really great filtration, in the bottom of the funnel, in the neck of the funnel. And the stuff having to pass through the cotton ball, that really filters it good. And I just got to put some coffee filters in here just to catch the bulk of the stuff and try to avoid plugging up the coffee filter or plugging up the cotton ball too soon. I'm going to wet the filter a little bit so it'll conform a little better to the funnel. All right. I'm going to take this stuff and I'm going to pour it in here. Now this has sat for a while, so the chlorine that was in it has had a chance to dissipate. If I was doing this immediately after dissolving the gold, I might put this on the heat and boil it just to drive off the excess chlorine. Because in the next step, when we're going to precipitate the gold out of the clean solution, if there was chlorine present, it would be an impediment to getting the gold to precipitate, because the gold would try to redissolve as quickly as it's trying to precipitate. And I've seen that happen before. So, but this has had a chance to sit around for a while. I don't really smell any chlorine, so I think it's probably good to go. So we're getting a nice clean filtrate down there. The cotton ball trick works just great. Everything is getting filtered out of the solution. Now it's slow. This is slow, and if you've got a lot of solids in your solution, it's going to take a while because things get plugged up. What I'm trying to do here is I'm just pouring the liquid off first so I can get the bulk of it to go through before I get the solid nasty stuff in the bottom of the beaker, because that will really gum up the works once it's in there and starts plugging up the filter. So having the liquid go through first speeds things up tremendously. I just don't want to dump all the solids in there right off and plug up the filters. But that's a nice, beautiful, clear filtrate. And it's about the right color too. Maybe a slight green tint to it. Not surprised. There's probably a little bit of base metal dissolved in it still. Not perfectly clean. But with precipitation, we'll get good clean gold out of it. And then if we dissolve that gold again and reprecipitate it, the gold will be even cleaner. Because every time we do this, we're going to leave other things behind. Now, you do lose a little gold each time. That's kind of unavoidable. So how often you want to do it is up to you. I generally shoot for like 3 times, dissolve the gold and reprecipitate it before I decide it's good enough. Then it's off to the jewelry store with the gold to sell it, and they'll tell me how good it is when they put their meter on it and tell me how pure it is. But I like to get it as pure as I can before I take it over there, because the purer the gold I take them, the more money they pay me for it. So this is going to take a little while. I'm going to dump the rest of this in there, including the filter. It's in there. Now, I'm going to rinse everything out of this beaker into this one. And it's important to note, I'm using distilled water now. Up to this point, everything I've done has been with tap water. But we've reached the purification stage now. We're trying to purify the gold, and we don't want to introduce any other impurities into the gold. So everything I do from now on, I do with distilled water only. That's very important. So I'm going to let this drain down, and then I'm going to rinse the filter, try to get all the color out of it, because the yellow color is gold. That's the color of chloroauric acid. So I'm going to need to rinse the filter and, you know, the cotton ball, and keep doing that until the liquid runs, until the filter's white and the liquid runs clear. Then I'll know I've got all of it out of it. But I'll probably still have a little bit stuck in the filter, but I have a container I put all my old filters in, and periodically I will process them and recover whatever gold is still in them. Let's start cleaning the filter here. This is going to take a little while. Take a couple of cleanings. It takes a while to drain through because now the filter's loaded down with all the particulates that were in the bottom of the beaker. So I won't make you watch this whole thing. I'll just turn off the camera while I continue this, and then I'll get back to you for the next step. Okay, filtration's done. I've washed out the filter. I'm going to take the filter and I'm going to put it in my used filter container. This contains everything I used for filtering gold. Every filter I've ever used. Anytime I've spilled any gold containing solution or anything and wiped it up, the paper towels from that are in here. The cotton balls I stuff in the neck of the funnels, they're all in here. Everything's in here. So there's still going to be traces of gold in this, and someday I will process all this stuff and get the gold out of it. So there we go. I'm just going to set this aside, out of the way. We've got a nice clean solution here. It is just crystal clear, yellow, pretty, just the right color, nice and clear. So we've got all of the solids out of it. I'm going to cover it up so nothing gets in it while I get set up to precipitate the gold. So that's coming next. I hope you can hear me over the droning of my fume hood. As I've said before, you don't need a fume hood to do this, but for this step, it comes in really handy. Of all the nasty smells and noxious fumes that are emitted in every step of gold recovery and refining, I gotta tell you, this step is the thing that bothers me the most. Precipitating the gold with sodium metabisulfite. It produces a lot of sulfur dioxide gas, and for some reason the sulfur dioxide gas is just bugs the hell out of me. So it's the reason I built this fume hood. So I'm going to put some spoonfuls of sodium metabisulfite into this liquid. There's going to be a fizzy reaction. A lot of sulfur dioxide is going to be produced. You should see a neat color change, and when that color change happens, that's the gold precipitating out of solution. So I'm using Stump Out. It is a commercial stump destroyer. You can buy it in a lot of hardware stores and home center stores. You can buy it online. And it's pure sodium metabisulfite. You can buy the lab grade stuff or the food grade stuff. I would recommend actually using food grade stuff for the final, the very final precipitation of gold in a multiple precipitation step, just to get the cleanest, purest gold you can. But for now, I'm going to go with the commercial stuff. So here's the first spoonful. It's a little cool today, so the reaction's not really vigorous. But at some point, we should see something happen. Stir it up a little bit. The yellow color's fading. Turning brown. That's what we want to see. I'm going to put a little bit more in. Well, it's getting browner by the moment. I don't know if it needs any more, but I'm going to put a little more in just to be safe. No real hard and fast rule on how much of this stuff you need to use. Now the liquid is turning very dark. That's what you want to see. That's fine particles of gold precipitating out of solution. They're so fine that they look black. So that's exactly what we want to see. So now we just have to wait for the gold to settle. And that could take a while. The gold particles are really, really fine. It could take a while for them to settle out of solution. It could take overnight. I have found that, oh, got a whiff of the sulfur dioxide operating with the doors open here. I have found that if I turn the heat on and bring this liquid to a boil, that the gold will come out of, will precipitate out quicker and actually kind of form a sponge a lot of times. I'll turn the heat up and we'll bring this liquid up to a boil and we'll see what comes out of it. And later, I'll test the liquid and see if it needs more sodium metabisulfite, if we got all of the gold out of solution. Don't want to leave any gold in the solution. We want to get out as much as we can. Okay, the liquid came up to a boil. I took the lid off so that the sulfur dioxide fumes could escape better with the steam. And the liquid has cleared up a lot. It's probably not real obvious inside the fume hood here where it's dark, but the liquid has cleared up a lot. A lot of the gold has settled to the bottom. So I'm going to turn the heat off. And I'm going to take it out. And we'll get a look at the gold that's settled on the bottom. Okay, I've taken the liquid off the heat. It's cooling down. There's the fine gold that is precipitated and fallen out of solution. It's on the bottom of the beaker. And you can see it slowly dropping down as I tilt the beaker. It's fine gold. It'll even float, which can be a problem. We'll deal with that later. The liquid is cleared up a lot. It's a little brown, which tells me there's some fine gold still in the water column that hasn't dropped out yet. I'll let it sit. The boiling kept it agitated, so not all the gold dropped out, just the heavier stuff. So I'll let it sit and let the finer gold drop out of solution, and then we'll deal with it. Next, I need to test this solution to make sure that all the gold has actually precipitated, and for that I'm going to do a Stannous chloride test. I'll get set up for that and show you how I do it. Okay, the liquid is off the heat. It's cooling down slowly. What I want to do now is a Stannous chloride test to ensure that I got all of the gold to precipitate out of solution. Now there's still some gold suspended in the water column, but that's solid gold. That's not going to affect the test. Just gold that's still in solution is what I'm looking for, just to make sure I got it all out. So I'm going to do a Stannous chloride test. Take a few drops of the liquid back in there, and a few drops of this fresh Stannous chloride solution I made just the other day. You know it works. And I got basically no reaction. The liquid is not turning brown or black, so that's great. So that means I have got all of the gold out of solution. Good. Now, like I said, there's still some gold suspended in the water column here. And the liquid, yeah, it's still a little cloudy. There's still some gold suspended in it. And it's sort of a little greenish yellow color. Since there's no gold left in the liquid, I suspect the yellow color is from iron, maybe? And the greenish is probably from copper. So we got a little bit of contamination left in the liquid, but that's okay. Precipitating the gold left that contamination in the liquid. It's not in the gold anymore. We got most of it out. So the gold that's down here in the bottom of this beaker is pretty darn pure gold. Now, it's not pure enough by my standards yet to take it to the jewelry store and sell it. I will dissolve it again and reprecipitate it, and then dissolve it again and reprecipitate it. And by then, the liquid should be perfectly clear because I've gotten all of the other stuff out of the gold. But we're not done with this gold yet. I need to let it sit a little while longer, cool off, sit, let the gold still in the water column drop to the bottom, and then I'll decant the liquid off and we'll clean the gold. We'll give it a couple of cleanings with hydrochloric acid and then some cleanings with distilled water. And I'll show you what the gold looks like after all that. Alright, so we've got the precipitated gold over here. Some of it's very fine and likes to stay in the water column. So what I'm going to do is I'm going to filter this liquid through a funnel, again with cotton balls stuffed in the neck. And here I've got 2 cotton balls stuffed in there. So the cotton balls should catch even the fine gold. I'm not going to bother putting any coffee filters in the funnel because some of this gold is so fine it'll just go right through the pores in the coffee filters. So there's really no point. So I'm just going to pour the liquid through the funnel, and what comes out hopefully will be nice clear liquid at the bottom, and we'll have the gold trapped on the cotton in the neck of the funnel, and I'll be able to wash the gold then. I'll be able to dump some hydrochloric acid over it to wash it, and then dump some distilled water over it to wash it, and we can do that a couple of times to get whatever impurities are stuck to the outside of the gold off of it, just to further purify it. So I'm going to start pouring, and again, being a bad example here, I'm not wearing my gloves. I want to be wearing gloves doing this, but just start pouring this liquid in. And letting it filter through. And so far it looks like it's coming out nice and clear, whereas that's got a lot of gold suspended in the water column. So good. The gold's getting caught on the cotton balls, which is exactly what I wanted, so we don't lose any of it. So I'm going to go ahead and filter this all through, and I'll show you some of the washing process when we get that far. Okay, so I'm filtering the liquid off the gold. I'm trying not to pour the heavy chunky gold that does settle to the bottom into the filter. I'm just trying to get the liquid off, and any gold that's suspended in the water column can get caught on the cotton balls down there. It's also settling out on the side of the filter, so I'll need to wipe it down after this process. But the liquid's coming through nice and clear. It's got a little bit of a green color to it, so we're getting some impurities out of the gold. That's good. Every time we dissolve and reprecipitate the gold, we leave some impurities behind in the water. So that's a good thing. The gold gets purer and purer. So I will keep decanting off the liquid a little bit at a time. Like I said, I've got a couple cotton balls stuffed in the neck of this filter, and I've got them stuffed in there tight. So the filtration is slow, but it's thorough. I'm pretty positive there isn't much, if any, gold making it out of this funnel. It's all staying in there. And the bulk of it's actually staying in the beaker. So I won't make you watch the whole thing. I'll be back. Okay, I've rinsed the gold a couple times with muriatic acid and decanted the liquid off through the funnel. You can see the gold caught, the fine gold caught on the inside of the funnel and on the cotton balls down there. The heavier gold stayed in the beaker. So I rinsed it a couple times with the muriatic acid. I rinsed it a couple of times with distilled water. All the gold stayed in there. There doesn't seem to be any gold down here in the liquid, which is good. So what I'm going to do is I'm going to transfer the cotton balls back into this beaker, and I'm going to take another clean cotton ball. I'm going to wipe down the inside of the funnel and get all this fine gold that's stuck to the inside of the funnel on the cotton ball, and I'm going to put that cotton ball in here. Then I'll have all the gold back in the beaker with a couple of cotton balls, and I'm going to redissolve this gold and reprecipitate it. So I'll show you that when we get there. Now for something really important. How to deal with the liquid wastes generated by this process. I have 2 buckets here. One bucket, the gray one, is my stock pot, and the other bucket is my waste treatment pot. And what happens is All the liquid waste from gold refining, I dump into my stock pot. And the stock pot, it's hard to see, has a bunch of scrap copper in the bottom of it. And I periodically add more copper to it because the copper gets dissolved by the acidic solutions that go in there. But the purpose of the copper is it drops the or cements out the any precious metals left in the gold refining solutions I put in here. So any gold, platinum, palladium, or any other precious metals get cemented out and wind up as a black sludge in the bottom of this bucket. So I just dump the gold refining solutions in here. And when the bucket fills up, I'll let it sit and settle for, a week or two. And then I will transfer the liquid contents of this bucket to this bucket, the waste treatment bucket. The waste treatment bucket, it's just kind of hard to see, is full of scrap iron and steel. And it's kind of hard to see because it's all plated over heavily with copper. And what happens is the liquid from this bucket goes in here, and we've got the same process again, but working with the iron. The iron will exchange places with the heavy metals in here, mainly copper and other heavy metals. And the iron will go into solution. And what you'll wind up with is a liquid in here that doesn't have any metals in it heavier than iron. And this liquid in this bucket then is safe to dispose of because it doesn't have any heavy metals in it. All the heavy metals are plated out on the iron parts in there. So the liquid in here is actually safe to dispose of. So most people who do gold refining have this sort of setup. They have a stock pot bucket and they have a waste bucket. That keeps the heavy metals and the toxic chemicals out of the water supply, which we don't want to pollute our water supply. It's bad and it's illegal, so we don't want to do that. So we want to treat all our waste before we dispose of it.